All right, welcome back to another LeetCode problem. So I think I have tried this one before. Yeah, but some time ago. So this is LeetCode 34. Find the first and last position of an element in a sorted array. So we're given an array of integers nums sorted in non-decreasing order. Find the starting and ending position of a given target value. If the target value is not found, return -1, -1. So I guess this is the first occurrence and this is the last occurrence of that value in the array. You must write an algorithm in logarithmic time. Okay. In an interview, we're not going to be given that information. We need to come up ourselves with that, but searching in a sorted array, that should immediately ring a bell and remind you of the existence of the magics of binary search, right? Okay, so let's look at the constraints next. So we might have no elements in the array. Interesting. That's an edge case. The values are positive or negative. And nums is a non-decreasing order. And the target value is in the same range as the values that are in the array. So perfect. Cool. So let's look at this example. So here, well, obviously, you know, the naive approach is just O of n time and O of one space, where we just iterate through all of the elements in the array. And then we just find the first occurrence and the last occurrence of something. So that's very easy to implement. And maybe we should just do this right away, just to get it out of the way. Yeah, why not? Let's do n of n time and O of one space. It's kind of the brute force approach, right? For I in and n in enumerate nums. And we have a result array, correct? And we have it set to -1 and -1. That's the default result when we don't find anything. And I should give it the honor of a complete variable name. There you go. So if n target, in that case, result at index 0 equals minimum well, we need to find the first occurrence. So if we find the target value, we have to check if it's the first or the last occurrence, or maybe a middle occurrence of that target value. So if result index 0 is smaller than 0, that means we found the first one. So what we will say is we'll just say result equals I. There we go. That's the first and last position we found at the moment. Now, if that is not the case, we'll just update result at position 1 equals I. There you go. And that should do everything for us. Let's run this real quick. Boom, test cases pass. All of the test cases pass. Right, so this is the naive solution. Now let's try to find one in log n time, logarithmic time, and constant space. So that's the next task. And for that, let's have a look at the example. And we're going to use a binary search approach. The difficulty is going to be to find, you know, the first or the last occurrence of a value. If it's guaranteed that a value is only occurs once, we can use a very simple binary search that just narrows down the left and the right point until we point at exactly that element. But here we have to take into account that there are multiple 8s, for example, here. So let's do this. So we have 0 and 1, 2, 3, 4, 5 -1. So 0 and 4 are the indices for left and right. Right? In binary search, we always have an approach where we have a left and right pointer. And left in the beginning points at index 0, and the right one points at the last element in nums, which is at length of nums -1. The left points at the 5, right points at the 10. Cool. So now we have to do our little loop here. While left is smaller or equal than right, That means we still can, the pointers can still move closer together. And we have to compute the mid value equals left plus right. We do an integer division by 2. So in this case, we have, I forgot already how many ends we have here. So this is 5. So 0 and 5. So 0 plus 5 is 5. Integer division by 2 is 2. So we're pointing at index 2. 0, 1, 2. So we're pointing at 7. Now 7 is smaller than the target value, right? If nums at mid is smaller than target, what do? Well, we set the left pointer to mid plus 1. That's what we do. Other cases, if nums mid is larger than the target, well, then we have to, continue to narrow it down to the right, to the left side of mid. So we have to adjust the right pointer to mid minus 1. Right, so these are the two cases that we have now. There's also a third case, else, and that is now when they are equal, when they are the same, right? Let's just write this here explicitly. So now what do? That's the big question, because we don't know if we should go left or if we should go right. We don't know. Well, so we have to decide, okay, are we going to look for the left target or for the right target? That's what we have to decide, basically. And whenever we're trying to find for when we're looking for an element that might be contained multiple times in an array, and we use a binary search, typically means we're looking for either the first occurrence or the last occurrence, something like that. And in that case, we have to decide, okay, are we now looking for the first occurrence? Well, in that case, if mid lands on, let's say, here, it means if our current value at mid is larger or equal to our target, we still have to continue searching in the left side array. So if our mid value is larger or equal, and we have the equal part here, we have to do the same thing. We have to narrow down the right side to mid, but we also have to remember where we saw that target value, right? Target equals mid. That's where we saw that. But we call this the pivot. And the pivot in the beginning equals -1, signaling that we didn't find it. And then we return the pivot. So this is actually the function for find first occurrence. So we have nums and target. That is what that is. So that finds the first occurrence. Now, for the last occurrence, it's very similar. Last occurrence, except when our mid value is equal to the target value, we want to continue search. So if we go here, now mid value is the same as our target value 8, means we want to continue to search here. So what we do is we adjust left to be mid +1, but we remember that we saw the element at that position, right? So, and we're only updating that position when we go left. So in the beginning, we split the array in two. We go left one step. Now, is there more time to go left? We go left again. So the pivot is only ever increasing when we find the last occurrence, when there's a match due to this statement. And the same with when we find the first occurrence, it's only ever, well, decreasing. So that means it's guaranteed to find the minimum occurrence of it. Right, so that's that. And all we need to do, return, well, the first occurrence, nums target. And of course, the last occurrence. That's what we have to do. We could also check if the first occurrence was already -1 and then the last one is going to be the same, or we could do this. So fingers crossed that I didn't make any code errors or typing errors. I'm not gonna check. And that works. And now we submit it. And it works as well, yeah. So, well, what can we learn from this? Well, this is a good practice problem to practice binary search. And if you've understood how binary search works and with the pivot, that's gonna unlock so many problems for you that you can then solve. So this is definitely something you should practice. And, you know, I know there are people who use like Python built-in functions like bisect. Why? It's not necessary. Just do this and shine with your algorithm skills, my friend.